Okay, there we go. All right, folks, welcome to the Wednesday, August 9th Ambient Weekly Contributors Meeting. So first up on the agenda, I just want to ask the Ambient area leads, how are we doing on creating the issues to track the beta release? Are these all in the GitHub issues list now? And if so, we can start get the board started and start assigning work items.
I think the answer is poorly, unless someone's done a bunch of work that I haven't seen.
Okay. I hate to nag people, but in this case, I'm going to have to nag. I will work with you guys offline to make sure we get these created.
Nagging is appreciated if it helps us get to the beta in time.
Yeah.
Because just one quick thing on timing for beta, we have 119 is getting released in late August.
29th, end of this month.
Okay, so that, what does that put us at for our planned beta release?
120 should be end of November if you just plus 3 months.
Plus 3 months, okay. So that's our timeline. That's our due date to
correct
get all this stuff done.
Okay. Next item is Kevin.
Yeah, sure. So yeah, if you can pull that up, I can kind of walk through the discussion here. It's related to the ambient, because I want to propose some ztunnel changes to the workload discovery service. And I think that's the kind of thing we'd like to get done while we're still in alpha. And so this here is kind of a summary of like what I see the problem as and some potential solutions. So yeah, just to kind of get the spirit of all this, there's a lot of text here. So just to walk through it, the idea is basically I'm concerned about races between like the ztunnel perspective of the world and Istio-D's perspective of the world when we do network and IP address lookups. That's the spirit of the issue that I want to talk about here. Just as a kind of a quick recap at the top, I kind of remind people how network works, and similarly for the IP address. I'm not as concerned about IP addresses lookups being out of sync because we have remediations for that already built in. I'm more concerned about network. So we could talk about the IP stuff, and I think I cover it there, but it's kind of orthogonal. John, yes?
Yeah, I'm a bit confused why we care about dynamically changing the network of ztunnel when we've never supported that for any Envoy data planes in Istio.
I think if you update the network for, like at the very top, how my understanding of how network works, if you update the Istio system namespace, all the pods inherit that if they're not labeled with that network. Right.
But all the pods get the network injected and the injection static.
Sure, they get injected in their static. Steven, yeah?
It's more like the ztunnel would have to be restarted to get all of the pods that.
Sure, but so does the Ingress Gateway and the.
I think isn't the proposal not actually to do the dynamic update if we go down?
The proposal is to make ztunnel not aware of its own network.
Right, yeah.
The proposal is to remove network altogether from ztunnel and have it just know things as being like on its network or not on its network. That's the proposal.
Right, but the proposal is introducing a ton of complexity to solve what seems to be a non-problem that's already existed in Istio since its inception. So that's what I'm concerned about. Like, I don't know why we need to solve this problem when it's already exists in Istio, and I've never once heard anyone complain about this. Like, it's not like networks are changing on a day-to-day basis, right? That's kind of a static thing. Like, does anyone think you can change your network in Istio today and things will just work? It seems.
Let's not forget that we already have all the problems if you update ztunnel, or anything on the node, it will probably break connections, cause traffic loss. So the only safe upgrade path is actually to restart the node really today. So if you change network, probably you'll do a node update, a rolling update, or something similar. There is no really good solution for not losing traffic.
I don't see why ztunnel even needs to know if something's on the same network as itself. I think it actually is more just the ztunnel needs to know if source workload and dest workload are on the same network, which is we can totally do with WDS, and it's not that hard to solve.
I agree. I think it's less about the ztunnel dynamically updating itself and more about what the source of truth for the network is.
So can you explain again what is this network? It's a CIDR for that particular node. I mean, it's a pod CIDR local network, or it's a different network.
We're talking about like the Istio opaque network IDs that say, do I need to go through a gateway or not? Like, is this going to be directly reachable?
For the multi-network.
Yeah, I mean, I think that this is a matter of auditing our usages of like the Istio meta network or the whatever network M that environment variable that the ztunnel has, and just trying not to use them. And in all cases that we possibly can, use information from the workloads that we're serving on behalf of or proxying.
Don't we already have a mechanism? And Istio is telling ztunnel where to go. I mean, to a waypoint, to a gateway, to whatever.
Yes.
So what do we need to change?
We need to just get rid of a config field, in my opinion, and consolidate on just using WDS.
Yeah, for example, let's say I had to take a while to think about like how this could become a problem. And for sidecars, yeah, the network, you have to like cycle the pod, they get injected at regular traffic routing. But if I like spin up new pods on different networks and ztunnels remain static, can you get failed lookups? I guess not. If you assume that you can only do it at installation time, then I think you're right, there's not an issue. But today we support, you can add that label and to the Istio system namespace, and everything's that are deployed will pick that up like live. That's the way it works today with sidecars, right? You're saying it's not how it works. That's my understanding of how it works.
I don't see anything in the code that dynamically updates the network.
What would happen would be like if I have a sidecar on network 1 and all my non-injected, non-Istio pods that I'm talking to, all of a sudden I update them to be on network 2. I'll stop trying to send to them because I'm like, okay, this isn't Istio. It won't do MTLS. I can't do SNI pass through. So you will dynamically update like your destinations networks, or really you'll just like stop mapping, or you'll try to map the gateway and you can't.
Yeah, but each envoy thinks that it's on the wrong network, which is the same that would happen with ztunnel, right?
Sort of.
It's actually it is really the same as ztunnel. I feel like the actual proxy thinks it's on the old network, but the XDS may be updated with the new networks of the other things.
I just don't think it's very difficult to solve this if we just rely on workload discovery service, because we don't care about what the proxy's network is. We care about what the source workload's network is, right?
Which proposal are you saying is the easy solution that we should do?
The idea at the very end, I kind of walked through my thought process, but at the very end, the idea is just to get rid of network altogether from WDS and just change it to a bool that's like on source or on remote. And anytime we look up something remote, we actually use the primary key.
I actually did not understand.
That was my... Okay.
Yeah, I'm not a huge fan of that approach because one of the goals of a WDS was to not be client aware, and may be willing to break that if it's for a good cause, but this is not a good cause in my opinion.
Yeah, my proposal is just that the ztunnel has no idea what network it is, and it doesn't care if workloads are on the same network as the proxy. It just cares what network workloads are on. And we assume that like if this thing is able to get, if some source is being proxied through Z-tunnel outbound, then it must be on our network.
Yeah, I thought that was the design from the beginning, that STOD tells Z-tunnel what to do, and there is no other information except the one from STOD that should really matter. I mean, if whatever STOD tells you to do, go to this gateway, go to this whatever, east to west gate or whatever, it's always determined by STOD. So if it's not that the case, then maybe we should make it.
Yeah, I think what Steven said seems to make sense to me, and I would be fine with that proposal. I mean, we probably have to look through if there's other edge cases, but that seems fine. Do we already support doing an on-demand lookup without network? If not, we would need to make that happen as well.
Yeah, that's the only thing I can't think of how we would deal with is like, I guess it's only, yeah, when you look up by IP, you need a network to make sure you look up the right version if there's overlapping.
Yeah, but we could say something, you know, if they don't set the network on the on-demand lookup, then assume it's from their local network, which we derive from something, maybe. I don't know how we derive it, though.
Yeah. The alternative proposal, which I think they started, which was like the dynamically setting network, would be if like all of the proxy config was dynamic and network was a part of that.
Wait, you still need to know the network where the Z-tunnel is residing on. So when you connect to STOD, you still need to tell what network you belong to for overlapping network and other stuff.
Well, STOD can try to infer that based on namespace label or something.
You cannot really. We discussed it a long time ago. We didn't find any way to do it. I mean, if STOD is a shared, whatever configuration is called, where one STOD serves multiple networks and has a public address, you know, the connection to STOD goes to NATS, go to whatever, and we kind of lose. We cannot determine really from the peer ID anything. It needs to be passed somehow.
I mean, we use the namespace label and then like pod label and like a priority ordering today. We can kind of make that match here.
You have two clusters, you know, with overlapping IP. You connect to STOD, to same STOD. They have the same namespace, same label, same everything. Just, you know, they have the same IP even. How do you know which network it is? That was the problem. And it's not a big deal. I mean, sending the network, you know, it's not. We can send it in a header, in a metadata. It doesn't have to be part of. It's just something that STOD needs to know what start. It doesn't have to be in each message or anything. Just.
Yeah, but I do agree with John that like if things do get out of sync, it's not catastrophic. I think like it's a major event anyway. Restarting Z-tunnel is acceptable, just not optimal.
If they got out of sync, isn't that a security? You could look up an IP and get a workload that's not yours and then start using it cert. Is that not a CB? That's not an attack vector? That was my concern.
It is. I mean, if it's the same IP, you get the different identities, and that's the biggest problem. IP reuse and if IP you get because MPLS doesn't help. Since we tell you what to verify.
Right, so we can't let them get out of sync ever.
I think taking a step back for a second, if that's right, if that's the failure, that's an unacceptable failure all around. I think we can agree on that. So the question is, do we have a metric that we alert the user that they need to restart their Z tunnels, or do we say that you can't run it? Or do we create a solution where you can't be in that situation?
To be honest, I don't even imagine, I cannot even imagine how this case will happen. I mean, you are in a network, you try to connect to an IP address of a pod in an overlapping network. It's not even possible at connectivity level. I mean, it's not, you cannot express it actually to an IP address.
I think you could express it. So let's say you were doing like an upgrade or something. You were adopting network features or functionality. So you started from a blank state, or you had a different network and you wanted to rename it, and you had one IP and one network that was remote by workload entry, and another one that was on your local network, and you happen to change from one to the other. Then IPs happen to match. You could then look up that other workload.
So different networks are based on IP ranges. I mean, your network is 10.1.1.0. All the IPs that start with this address are in your local network. You connect directly, you don't have any problem.
Well,
if you have another one, it's a very, we don't even support it today. I mean, today East-West gateways only support services. We route by service, not by IP, because for the same reason.
The attack vector is a workload entry, so it doesn't have to be a real IP that actually exists, even if you segment them. I mean, as a malicious user, I can create a workload entry with any network and any IP. So I just have to identify that you changed your network and what you changed it to and from, and then I can start like mocking or swapping identities, right?
Yeah, I know, I understand. I understand that, and you're correct, but I'm not sure the use case of connected to an IP in a different network needs to be supported in the first place. I mean, we should filter out any IP from other networks because we don't have any way to address them. How do you know 10.1.1.1 is in network A or network B if they have overlapping spaces? We don't have any way to indicate it. Do we even support this feature today? I mean, how does it work to connect to 10.1.1.1 in two different networks to overlapping spaces?
We don't today. My concern is that we can't address it in the existing like WDS API unless we change things. And I'd like to do the break soon rather than later.
My point is, we cannot address with network as it is today defined. I mean, IPv4 cannot do this. There is no way to intercept an IP and then figure out magically which network it. I mean, you go to cluster 1, cluster 2. Maybe IPv6, but then you don't have overlap.
zTunnel gets a request to a service, and then we pick a specific workload and we send it to that network gateway, and then we can.
No, but service is different.
Yeah, you can't receive a request to a pod and then
exactly
enter that pod in another network. That is yeah.
And for service, we have MTL as a service, secure naming or whatever. So you cannot have basically any attack on that surface. I mean, it's only pod to pod that would be vulnerable.
Kevin, are you saying like you'd be able to spoof the source identity? Is what you're saying, right?
Yeah, the source lookup is the one that's going to be wrong because the zTunnel has the wrong view of the network, like a dated view. But the source has to be on your, yeah.
So I used to have a pod at like 10.0.0.1 that had service account A. I changed my network to B, but my network in my zTunnel is still A. Now something on A has a different service, or something with that same 10.0.0.1 has a different service account, and I'm getting that service account incorrectly, is what we're describing. So it's kind of an edge case where not only am I updating my network, but I'm like reusing names that I had before. I guess the empty name would be the concern, but it's like if we're moving to network, but yeah.
Interesting point, John. You're saying there's no identity for workload entry. How do we do Istio MTLS with workload entry then?
You can't. Why would you have a workload entry for a pod? If you have this set up, then you're running on a VM and you're in the dedicated mode, which is like an entirely different world. It's not the shared zTunnel. It's like a sidecar.
Gotcha. Yeah.
Yeah.
That makes sense. That's
No, you may have issues
dedicated.
there that I haven't thought of, but I haven't thought as much of that mode.
I think at the very least, it might be helpful to come up with a more concrete. It seems like the pushback is exactly what the attack would be and how that needs to be addressed then. So perhaps a clearer example of exactly how that could happen is needed.
Yeah, to be honest, if the attack vector first starts with trick the Istio admin to dynamically change their network, you're already on your way to a 1.0 CVE. Like it's not something that you can do as an attacker. And it's not something any Istio user should ever do for any reason. I can't imagine someone dynamically changing their network in Istio and things don't break. Like that is not
What's our
something you
upgrade
can
path
do.
for people who don't have networks and they want to adopt one?
For sidecars or for ambient?
Just generally.
Sidecar first, I guess.
For sidecar, both sides have to have some value set. So if you're going from nothing to something, like we don't do any lookups with the network, so it doesn't really matter. It's like you won't go through a gateway unless both sides have a network set. If either one is unset, we just assume things have connectivity.
Do we have a talk about how multi-network is supposed to work with ambient? I mean, are we switching to the H1 on the east-west? Is the old east-west? And in general, the design for multi-network with ambient, I'm not sure if I saw any doc. Are we assuming it's the old one? Because pod-to-pod definitely falls outside. It was never supported, and maybe I'm out of the loop. Okay. Thank you.
So I know John presented a doc like 2 months, 3 months ago, maybe.
It's probably older than that, but yeah, I think Stephen
Yeah.
linked it.
Oh yeah, cool, thanks. Yeah, so Kevin, I agree with what you were saying earlier. So I think the key is does this break user, how it'll break user, and also compare with sidecar case. Because if for sidecars, do we have user complaining about this? And if not, then maybe it's not as a big problem.
Yeah, I'm still, frankly thinking I don't want to dominate this meeting and take too much time when I'm spending so much time thinking, given the feedback I've already received. But my primary concern is I want to make sure that we have, like, I understand John's point about the permissions already required to change the networks. So if we have a reasonable, like, upgrade path to like adding a network or changing networks in ambient, and then we're fine with it being static, I'm okay with that. My primary concern here is making sure people who already have Istio deployed can adopt ambient and can adopt networks in a way that's not being, you can't attack. But I need to think about that more.
Okay, are we ready to move on to the next one?
Yeah, I think Stephen has a question in the chat. Maybe we can quickly discuss that before we move on.
It's just the idea. I can put it in the issue and we can kind of discuss it async. I don't want to take up too much more time on this.
Stephen, can you just capture that in notes?
Sure.
All right, so next topic is Keith.
Hey, I was kind of tossing this idea around, but I wanted to see if folks are would be interested in having a GitHub group for ambient maintainers. The reason I ask is because we have one for zTunnel specifically, but a lot of the work we're doing with ambient can be cross-cutting and requires multiple working groups, quote unquote, like working groups anyway. John mentioned that there was some conversations happening about the working group structure in general. Just wanted to see if there's appetite for it. The context for this is, I'm putting together some architecture diagrams and such in documentation in the Istio repo, and we needed some code owners. And then I realized that, oh, there's not like just an ambient group. And in theory, you could have every working group listed under the ambient directory. So don't know if anybody had thoughts or had similar feelings about an ambient group.
Yeah, I think we discussed this a while back ago, some similar line of the idea. I recall one of the concern from people is right now the review and approval are pretty much by GitHub directories, right? So people are maintaining those files for sidecars. They want to also to be involved on ambient change so they can make sure the changes are not breaking sidecar as well, which we have many users in production today. I mean, for docs architecture, that's probably fine. I think we can loose that up. But for code, there were concerns about people working on sidecar and not having enough visibility onto those.
That makes sense. Yeah, because you need for some of that core code, you need both. I guess do we have any concerns about the inverse of that, where folks who are working on sidecars don't have ambient context, and like wouldn't be able to review ambient specific PRs?
That's a good question. I mean, I think that the ambient meeting has more user than the sidecar work group meeting. So maybe it's less a concern from that perspective.
Okay. Then I think that convinces me, because it seemed like there is a big need for it. So for the PR in question, I'll just put the zTunnel users as well as general, I think general networking is what I've got there now. And we'll just kind of get more data, and if something changes, we can talk about it again. That's it for me then.
Yeah, thank you, kids. And I'm glad people are reviewing your docs too. So thank you for creating them. It's not like you're not getting good response or anything. So that's good.
Oh yeah, totally. I was just thinking long-term organizationally, wanted to make sure that making the right code owners and putting things in the right place for sure.
Yeah.
Okay. Next topic is Stephen. Hey, Stephen, did you meant to add link to this doc, the zTunnel hairpin doc? Because the link is pointing to
Keith's like doc that's like in a PR. It's like
I see.
some of the diagrams, and it's kind of part of the discussion for that same doc.
This one here.
Right.
So this is a continued discussion from last week about hairpins?
Yeah.
All right.
Keith, you're a little bit more familiar with the way that this one's laid out. If you want to go over it, or I can try to do like a quick recap.
Yeah, can you present? It's just easier that way to navigate.
So okay, yeah, I can present. Give me 1 second.
Mm-hmm.
Okay, let me see if that worked.
Yep.
All right.
I see your screen.
Awesome. So I'll just briefly go through this. There's some good comments there. Appreciate the folks who've already taken a look at it. Basically, talk through peer authentication and its role in Ambient, and there in this section around peer authentication waypoint proxy, we discuss hairpinning. I think the open questions so far, based on what I remember from the doc, as well as the and actually let me go to this view so that folks can see the diagrams.
Yes, Stephen wants to open up the rendered version if you can. Yeah, thank you.
Yeah, there we go. So open questions here are mostly around one, should zTunnel apply policy before hairpinning to the waypoints? And by policy, you'll be more specific and say transport policy before it's forward traffic to the waypoint. The option 3 that we discussed in the hairpinning discussion mentioned doing the zTunnel waypoint communication over TLS. So the diagram currently shows, I actually have a disclaimer here for, yeah, right here, for some of this is not implemented yet. But the option 3 has the zTunnel waypoint communication to be over raw HPhone TLS, so vanilla TLS, not MTLS. And then there's an open question on, should this communication back be TLS or MTLS? John and Lynn mentioned that this should be mutual TLS, and my question is around which identity should be used here for an unauthenticated request. And then the alternate situation where this is an authenticated request, you've got the full workflow here where the source pod goes to its zTunnel and waypoint to the destination waypoint, and then back to the destination pod. So that's the diagrams that I made in the scenarios it captures. Oh, and then I mentioned here in the text where if the peer authentication is strict, then the traffic will be denied at the waypoint. I'm sorry, at the zTunnel before even forwarding to the waypoint. But yeah, those are 2 open questions. Should zTunnel apply transport policy before forwarding to waypoint? And should the connection back to zTunnel from the waypoint be regular TLS or MTLS?
Okay, I think I'm leaning towards the zTunnel would enforce it if it can enforce it before send to the waypoint, if it's a transport layer. And then I know I made the comments the waypoint to back to zTunnel be mutual TLS, but now I'm thinking maybe TLS make more sense, because if we do mutual TLS, which identity would use? We don't want to use the waypoint's identity unless because we need a way to convey it's also it's like unknown identity if we use waypoints identity for exchange mutual TLS back to zTunnel. So I'm not sure how to convey that. So it might be easy if it's just TLS.
That was my intuition as well.
Yeah.
That if something's unauthenticated, there shouldn't be any kind of mutual auth involved at all. And from a proxy perspective, both Waypoint and zTunnel can use the lack of client search to know that this is an unauthenticated request, and therefore not assume anything about the requester. Any other thoughts?
That seems a little weird and quite involved, honestly. So I'm just back from vacation, so I'm trying to catch up on this. We are talking about a situation where there is a source pod with no client certificate.
Yeah, out of mesh. Think about it. That's yeah.
Okay, out of mesh, but it is going through a zTunnel.
It's trying to call a target pod, and then the target pod zTunnel is going to say, oh, it has a waypoint. Let me send to the waypoint first.
Well, the istio-D is going to say that. Right, so it's going to
Right,
go through
true.
Z-tunnel. Z-tunnel says you must go through waypoint to get to target pod.
Yep.
Which means we have to tunnel the traffic because there's no way to go through the waypoint without us tunneling the traffic using Z-tunnel.
Correct.
So this is a pretty weird edge case, right? You have a pod running on a node with a Z-tunnel with no client certificate.
Not necessarily, right? Anytime you've got unauthenticated traffic going to a pod, the CNI is going to send that traffic to that target pod Z tunnel. If that target pod has a waypoint, it's going to hairpin to the waypoint.
Oh, okay. It's the receiving side hairpin you're talking about.
Yeah. So the source, the source may not have a Z tunnel. It could be on a different node. Yeah, the receiver has a Z tunnel.
I think it's the same scenario if it's on the same node with the Z tunnel, but it's just not marked for capture.
Yeah, that's right.
Could certainly see an argument for Z-tunnel forwarding to the waypoint in plain text, but anything coming back from the waypoint in would seem right. That should be over MTLS, right? Because waypoint should be the thing enforcing the policy. Otherwise, there's no reason to go through it. And you want to know on the Z-tunnel side that this is coming from a waypoint, so I should trust the fact that it has enforced its policies.
So the waypoint sends its.
So in this diagram, right, you have source pod plain text to Z-tunnel. Z-tunnel goes, oh, this has to go through a waypoint, and it didn't. So Z-tunnel to waypoint would be plain text, right? Because this is just delegation, right? There's no additional protection. Waypoint enforces policy, just like it would for anything else. Then it can be MTLS back to the Z-tunnel, and then from Z-tunnel plain text into the destination.
So two problems with that. The for Z-tunnel to waypoint, I don't know that it can be plain text because John was mentioning that from a protocol perspective, the waypoint can only accept H-bone. And then the second part of that is that the waypoint might be on a different node. So now
so the other alternative is to have a universal certificate, which is the no identity, right? And you can use H-bone.
So this was the in Stephen's doc. I don't know if maybe you want to go through that, Stephen, but we had kind of 4 or 5 options, and having a special identity for no identity
unknown.
Or unknown or something like that was one of them. But last week when we were discussing, we kind of circled around, hey, if we're potentially sending to a different node, we should do that encrypted. So TLS makes sense. Some sort of TLS makes sense, but we don't want to. We feel like it's risky to have the Z tunnel. Because today what we're doing is we're trying to guess the identity, which isn't great. And so
there's no identity there to guess. Yeah.
Exactly, for the unauthenticated perspective. So we would just use regular TLS as a way of indicating that there is no identity. This is unauthenticated, but we're going to encrypt the traffic because it's leaving the node. Was kind of the rationale.
Kit, let me clarify a bit. When we discuss this, what we discussed is that or what people were against was using this unknown identity and authorization rules and exposing it to user. It's not a problem if the communication between Z-tunnel to waypoint is even using Z-tunnel own identity, because again, we want to verify the request is really coming from Z-tunnel and it's encrypted. We know for sure it's coming from Z-tunnel. We can indicate somewhere that it has no real certificate. So the issue was, and why the point was rejected, the proposal was rejected, is users being exposed to this dummy identity and pretend to be MTLS. I mean, it could be MTLS with Z-tunnel authenticated itself, but from the point of view authorization rules and all the policies and APIs, it should appear as if it was if it had no certificate. Doesn't mean that no certificate was used on the wire.
Sure. Yeah. No, I get that part.
The other option that I think Costin brought up was just don't stop capturing any inbound traffic that's not on the H1 port and just let it through if it's not coming. If it's coming to a pod that is in the mesh, we only capture HBone. If it's plain text coming from somewhere else, we let it through, which is a little more drastic, but it would sort of handily solve this too.
And the main reason for me is that, affinity and all this, you have one pod, client pod and destination pod on the same node, on the same, kernel, and you have super high bandwidth. You can do all kind of stuff, and you have maximum security because it never leaves a node. You don't have to go to wires and slow down. And suddenly you want let's say it's a TCP database, and you want to have a backup or some machine learning that it's, you take advantage of affinity and everything. And suddenly you add a waypoint, and the entire thing breaks because it has to go to waypoint, it has to go back twice over the wire with MTLS. So all your performance is gone, all your security is mostly gone because it's now going to a different node that it's, so it has a very dramatic impact with zero benefit, because if it's TCP, you cannot do much policies. The main argument is that we do deny post, but if it's TCP, there is no such thing.
Right. So I mean, we already have the ability to force L4 authorization policy inbound, right? And we added the protocol selector, right? So people have policy control.
So if
There's a proposal for that.
That's where I disagree personally disagree with the proposal of not capturing, because if it goes, D-tunnel and waypoint are inherently policy enforcement points. Not enforcing policy because because it's plain text feels like a very unpleasant surprise for a user. To think that traffic goes through your policy enforcement point and doesn't actually enforce policy, I'm not in love with that.
That's true, but then the downside is we literally cannot enforce an entire subset of policy because we don't know the source identity. And so what you would normally expect to be able to write policy against, we're special casing say, if we don't know the source identity, you're limited to a subset of policy, which is also kind of a weird break, right? It's like we can't attest anything about the source, therefore these sorts of policy you can't write no matter what. Really is what I say.
If we use the approach that the gateway API is using to have some test suite that verifies that something works, it doesn't work, it will not pass the test, and it will be very bad for users because they will be confused. Some security will work, some will not. Nobody will know what works and doesn't work really.
I don't know if I'm sold in the scenario. Like, can't determine source identity distinct from does not have source identity? You can absolutely write policies that say if you don't have a source identity, then you are not allowed to talk to this workload. And in fact, that's
right. You can write policies saying that there is no source identity, therefore deny or do something. Right? You can do a denial policy, but you can't actually write anything that attests to the identity of the source because you don't have one. So we don't want people to be able to write policy that assumes things about the source identity or anything about the source because we can't prove any of it. Right?
Actually, it's worse than that. People have the ability to write this kind of policies by using network policy, because with network policy, the CNI implementation knows the labels of the source, knows everything. You can actually write very powerful policies for plain text relying on the CNI layer. But if we capture, we break that because the traffic from CNI will look like from Z-tunnel, we bypass it or whatever. So you lose ability to write policies with network policy, and you have no ability to write policies with Z-tunnel.
If Z-tunnel is enforcing the transport layer policy, how is that any different from network policy? We can check. In fact, network policy can't check identity. And the authorization policy for at the transport layer for Z-tunnel can, from what I understand, can do everything network policy can do. So how are we losing anything?
So that's not, unfortunately, not true. I mean, Z-tunnel doesn't implement network policy and cannot apply the same policies that network policy is doing because it's different implementation, different. Someone will need to implement network policy, and then why would do it because there is already network policy implemented. So.
Wait, hold on. We can check if we can check CIDR. We cannot do label. That's fair. But
that's the main point of network policy.
But I mean, if we've got CIDR and identity, so why would we want someone? Why would a user want? Help me understand. If the user, so the gap that I see in the user being able to write policy saying, "Hey, traffic from workloads with this set of labels can come through plain text with no identity." Why would the user want to write that policy?
Let me give you the simple case I mentioned before. You have two different pods from the same namespace, same service accounts, and everything. You write a network policy saying that everything with same namespace as I have, which is a very strong boundary in Kubernetes. So basically, my own workloads, they can sit on the same node and they can talk with each other with no extra. I mean, that's a policy. My own namespace can talk with each other, and no other namespace can talk with my workloads. It's very common. I mean, you develop a set of applications, they need to have communication between them, you trust yourself. So label authentication, especially the network, it's a namespace label, are equivalent not equivalent, but are powerful enough to express identity and more powerful than CIDR, which is in Kubernetes is kind of unenforceable.
So two things. One, I don't know if I'm sold on the namespace being a security boundary. That's a separate conversation. I don't want to get caught up too much on that. But two, if the situation with network policy makes perfect sense, but they're not meshed. The delta that we're talking between network policy and the authorization data structure that we have in Istio Ambient is labels. And so the only functionality that we're missing is to allow non-meshed pods to talk to ambient pods through plain text. That feels like a very big, it feels like very much like an edge case to me. So I don't know why that should factor in. Fundamentally, what the doc proposes, what we discussed last week, I think is about the hairpinning scenario where we have traffic that is unauthenticated to the mesh, and we need to decide how to handle it. This doc, as well as the option 3 in the proposal, the approach essentially is let peer authentication decide. Let peer authentication be the API for users to decide how they want to handle that use case. If peer authentication is permissive, then we will let traffic go through to the Z-tunnel. If you happen to have a policy, a separate policy that blocks the traffic, it'll get blocked right at the Z-tunnel. But if it's permissive, you can go to the waypoint via the traffic gets forwarded to the waypoint. To the Z-tunnel, it goes to the waypoint via TLS to designate that it is unauthenticated traffic, and then traffic comes back to the Z-tunnel through another encrypted tunnel. That's the proposal. I don't see a compelling use case for label-based security policy that is non-meshed. I don't know if I've ever seen that, but I might just be ignorant there.
Yeah, I want to add something here. If you look at the sidecar today, right, what Keith was describing from an out of mesh client to talk to a sidecar That's a very basic scenario we're targeting. And for sidecar, we're not requiring user to, write network policy for such a simple scenario. I think, now that we look at the scenario in Ambient, I think it would be too much to ask user for the simple scenario. Look, you have to use network policy to block this scenario. I don't think that would fly very well.
With current sidecars, we do not break network policy. So if users have network policies, and they should have, because if you, CNI encrypt traffic and provide authorization based on labels. Today with Istio, we say permissive means that you allow workloads without sidecar. But if you want any security, you need to use network policy, because that's the other authorization policies that exist. I mean, we don't require users to do it. We recommend them to use it to layer it on top of each other. It's kind of
so
basic.
they can use it layer on top of each other, but it's not a requirement, right?
It's not,
But
and I'm not saying it's a requirement.
I think what you are proposing is a requirement if we don't have any solution in Ambient. Maybe I misunderstood that.
No, my proposal is to not break network policy. So the user is layering and is using correct with Istio sidecars, it's using permissive with network policy, because they have, a network that encrypts, verifies labels, they are happy with it for some traffic. With this proposal, it will be broken. So whatever they have, I don't know if there are real use cases for CNI to provide network policy and for Kubernetes to provide network. That's a different discussion. But if people do follow our recommendation to layer network policies and Istio policies, and they do use network policies, we don't want to break them.
I agree with not breaking them, but there are caveats with Edgebone port, right? And there are caveats of it's different hops now, right? With sidecar, it was simple. It was just one pod, but now there's a Z-tunnel and waypoint. So I think it would be reasonable if user would have to may need to revise their network policy slightly because of the port is Edgebone port, and also because the architecture they have to take into consideration of Z-tunnel and waypoint now.
There is no scenario where they can write a valid network policy if Z-tunnel is a path, because they lose the labels, you lose the source IP, you don't have any information. So CNI cannot do anything really to apply a network policy with the current design. As far as I know, unless someone figure out how to do it. So and it's very black and white. You write a network policy, you apply Ambient, it's working or it's not working. We can write test cases for that.
Do we claim that Ambient supports network policy anywhere?
We claim Ambient doesn't break existing users. So we claim that when you adopt Ambient, Kubernetes will not be broken.
Where do we claim that? Where do we claim that? That feels like a pretty wide claim to say if you're adopting Ambient, your Kubernetes cluster, you won't be broken. That we can maybe aspire to that, but you're effectively network policy. That's two different policy enforcement mechanisms.
I don't think we document that at the moment. It's something I think that's desirable by many of us, I would say. Yeah. So I don't think Cilium even works with Ambient at the moment. Calico, I don't think that the policy enforced with Ambient either. So.
Right. So Flannel, any CNI, there's a number of factors that might that can determine whether or not Ambient will be a drop-in piece of software for you. And customers who know how to deploy software are going to be used to, okay, what are the compatibilities here? And maybe network policies are incompatibility. Maybe not an incompatibility, but maybe there will require changes to be made if you're going from one policy enforcement mechanism to another.
But why? What is the benefit for us to break network policy when we cannot really enforce, MTLS certificate-based policy? So we have a policy based on certificates. We know it doesn't work for plain text, and we are saying we'll still break network policy because what?
Hold on. In any scheme, authentication scheme or authorization scheme that uses plain text, that uses certificates for identity verification, is not going to work for plain text. That feels like a given. I might be misunderstanding the. Effectively, what I think we're discussing at this point is it sounds like what I'm hearing from you, Costin, is that this isn't going to work if we can't determine the identity, and that feels obvious, right? If we can't determine what your identity is, we don't trust you. Full stop. And so we're going to do things differently. That's the value add of a service mesh or any kind of MTLS proxy substrate. So it feels very much in line with the rest of Istio to expect a certificate, and if you don't have an identity, we're going to treat you differently. We might not deny you outright, but I think we do within our right to do that. But we're going to give users ways to determine how they want to handle, do they want to allow unauthenticated traffic or not? And do they want, and is that way to have a policy to apply?
I completely agree with you, Kit. I mean, if you have certificate, no problem. User should be able to say, if you don't have certificates, don't allow it at all. That's perfectly valid. But what I'm saying is, if the user says, I want to support workloads without certificates, I don't want to block them, then we should let it go and allow them to use network policy, which is encrypted. It has authorization, it's slightly different authorization mechanism, but it's equivalent with Istio in most practical ways. I mean, it's identity based. It takes into account the identity of expressed as labels. It is encrypted, and it works with Istio. It works with Kubernetes. There is no point for us to, I mean, unless the user say block all the traffic without certificate, we have no reason to break it.
So if we're in permissive mode, meaning traffic goes through, it uses TLS on the waypoint we're hairpinning. This breaks, you're saying this breaks network policy because we're hairpinning to begin with, and the IP is going to be messed up. Is that effectively what you're saying?
A lot of things will be broken. I mean, network policy will be broken. People will be able to. There is a whole bunch of things if we mess with it, because again, it's something that we are not equipped to handle. I mean, our design is based on certificates. You don't have certificates, there are too many holes to list.
I mean, if you want to, again, maybe I'm oversimplifying, but if you want to allow, and Francis left, I want to call out we're over time here, but the last thing I'll say is, like, if you want to write policies that allow plain text traffic and apply label selectors, couldn't you just, you obscure the original identity, that's fair. I mean, I don't see, my understanding with Ambient is that we wanted to move away from label-based policy. And if that's not the case, then you can re-examine.
I think we do want to do that for stuff that we have identities for, right? But this is stuff outside of us, our control, that we don't have any way to attest the identity on. So, like, if you want to do something out of our band with network policy, we can't stop you, and that should compose, I think, is what Costin is saying. That's sort of outside of our purview, right? You come into our mesh, then we have guarantees about source and des identity, and then we could do something different than labels. But outside of that context, we don't do anything, or we can't.
But it sort of doesn't compose today, does it? Like, if you say, I strictly require MTLS, and that's being enforced at the sidecar, and you have a network policy that says, yeah, let it go to the sidecar, it's still not going to make it.
But I think what they're saying is that for the plain text case, where we do allow traffic to come through to the sidecar, network policy composes on top of that, because we have the unmodified source labels, source labels and such, and Kubernetes can determine that because there's no extra hop and no hairpinning. So what Costin is saying, I think, is effectively an argument against hairpinning in general because it breaks network policy.
Okay.
Right.
Yeah.
If you want
it's
to,
not hypothetical. It's a very common use case in many networks, in particular in Google, but probably most of them. Traffic from load balancers and from infrastructure doesn't have certificates typically, or our certificates, and it's basically enforced. You verify that it's coming from the gateway through a network policy.
Yeah, right. Gateway. If you want to control stuff coming in and want to have identity attestation, you put a gateway in front of it and you funnel stuff through that. Sans that, it's not really our traffic per se, and that's the whole, like, just skip it if it's something we don't, it's not part of our mesh traffic. Yeah. I don't know. I just don't like the idea of inventing an identity, and I don't see a way around that entirely unless we do something really cute with the single leg TLS stuff. And I'd rather just skip everything except the HTML import if the alternative is generating nonsense identities.
Yeah, and to be clear, like we're not generating the
Yeah.
I guess it's not generating nonsense identities, but I think what we're losing is the ability to compose with network policy, which has like kubelet information about labels and not only kubelet, like API server information about labels and such.
Yeah, that's a fundamental issue. Breaking network policy and what people do with network policy if they adopt ambient. And I think that's a huge loss for the user.
So maybe ask a question here. So what if my source pod is not outside of the mesh? What if my source pod is inside of the mesh and my destination has a waypoint? Then we still need to go to the waypoint, right? So the network policy still needs to be modified to accommodate that flow of source goes to source Z tunnel and then to the destination waypoint and destination Z tunnel. So you still have to make changes to the network policy in that case, right?
Once you're in the mesh, though, that's the key. Like
once you are in the mesh,
we have
right.
more
Not
controls
entirely.
than network policy can give you, right? You're in our world now. We can give you much more controls around policy. We can give you more guarantees about identities than network policy ever can, right? That's the point about labels are only good up to a point.
And we bypass the CNI, so basically the network policy will not be enforced. That's a root problem because the tunnel pod is bypassing all the CNI and network policy checks. So that's why.
Okay, so you guys are basically not concerned of the case when source and destination are both in the mesh because we don't need the network policy because we have stronger identity and policy.
That's an upgrade, yeah, quote unquote.
Okay, but in this particular case, source is outside of the mesh, destination is, so you want to have the network policy continue to work.
Or the other way around, both of them are valid.
It's going to be tricky. Yeah, sorry.
Yeah. No, I was going to say the same thing. I'm going to have to think about that some more because this is definitely a decision point. I understand the I understand the argument now. I missed it before, but effectively, what we're saying is non-meshed traffic that is not designed to be used in mesh, that we shouldn't make ourselves incompatible with other identity mechanisms or maybe enforcement mechanisms that might have more context than we do on the wire.
Exactly.
Okay, and the specific functional concern here is from the sidecar model, L7 auth Z policy for plain text traffic would be in effect. With the waypoint model, without hairpinning, the only thing permissive could say is allow it through at L4 or not.
It's a bit more complicated because if we want to support network policies, we need to get out of the path. I mean, if we capture the traffic.
No, but like if yeah, I mean, leaving aside capture concerns for a second, right? But in the diagram, right? If it was plain text and all we said, and it somehow ended up in Z tunnel, and all permissive meant was let it go to the pod or not. Nothing to do with hairpinning. And assuming capture was allowing it to work with network traffic, you would maintain the compatibility, right, Custom?
If it got to the tunnel, it's already too late because we no longer have ability to enforce.
No. Like assuming that a CNI and capture mechanisms compose.
Yeah.
So we got the plain text traffic after it had been through network policy.
The problem is that our security model assumes or requires that if you have a waypoint deployed, all traffic is going to go through that waypoint.
We have an
because
API.
It may be L7. It may or may not be L7.
No, but we have an API where we can choose to let the user mean something other than that key, right? Now we're like inheriting the semantics of permissive maybe is a bit risky, right? And maybe we should think about what the API is supposed to mean.
Yeah, that's where my mind is going. Is there anything wrong with dropping the waypoint from the data path completely in a permissive setting. Yeah.
What if the traffic are not supposed to be allowed and we allow it? I guess that's the concern, right?
Well, then don't enable it permissive, right? Make it strict.
But that's the
you can't have a
default, though.
policy unless you have strict MTLS. Like that's not how our APIs really work, right?
No. So like this is obviously a behavioral change from how things work today, right? We have to decide if we're going to tolerate a behavioral change.
It's not, to me, it's not just a small behavioral change. So it's fundamentally our OXI API allows operating on plain text. So
right. So do we, like the options seem to be, do the hairpin, change the semantic of the API, and or tell the client, look, if you want to like have a plain text port in the waypoint, and you have to talk to them.
There's also nothing stopping a user from
using the API to declare that.
Oh, sorry, I thought you were done.
No, that's the three.
Okay. I'm realizing there's also nothing stopping a user from having permissive peer authentication and a transport layer authorization policy. So if you did want to write policy in permissive mode, you could still do that in Network Compose. And if it's transport layer, we wouldn't hairpin. Am I thinking about that correctly?
I don't know how.
Yeah, I'd have to think about it. Go ahead, Austin, sorry.
Okay, well, we're over time anyway. Let's leave on that. I think as far as meeting notes go, the decision point we're at is, does permissive peer authentication mean skipping the waypoint? And we need to think about the implications of what that means.
And it may be worth using the different kind of words, because we're using plain text, we're using permissive. In reality, is using encrypted and authenticated traffic with different policies and certificates. Because Cilium and most networks are encrypted and not plain text, and they have authorization policies that are based on labels, which are valid use cases. So
Well, yeah,
just
to be clear, plain text and permissive are related but different. Permissive is how do you handle plain text?
There is no plain text kit, that's what I'm saying. So traffic is encrypted. It's not encrypted in MTLS, but it's still not plain text. It's encrypted with WireGuard, whatever, IPsec and other mechanisms, but it's still not plain text.
Yeah, but Costin, that might be a little bit like, we might be tying ourselves up in knots, right? Like plain text traffic over a VPC that's encrypted, right? Like how do we know, right?
User should
we need
know.
our own user, maybe, but like we need our own, like our API can only express about the guarantees that we have.
So it's a different discussion. I agree.
Okay.
Okay.
All right. Yeah, let's take this offline. In the meantime, review the doc, think about this, and maybe I'll start a thread in Ambient Dev to flush this out some more, because I think it's an important question. All right. Thanks, everybody. Yeah. Sorry for the long meeting.
That's good stuff.
Yeah, good stuff. Thanks.
Thanks.
Bye. Take care.